This next section we're going to move into is about kinetic molecular theory, or KMT. This is a theory that's going to show up all over chemistry. So this is the first theory we've learned about in this chapter. So far we've learned about laws. We've had, Avogadro's law, Charles' law, Boyle's law, Ideal-gas law, and these tell us what happens in nature, right? If I increase the temperature, my volume goes up. It's what happens, and they help us to explain what we observe. But why are these laws observed? That comes into a theory, and so that's how humans, right? This is human-created, human-made, how we use a lot of different laws, try to piece them together so they're strong, and develop a theory that helps us to explain these laws and these observations. So again, this theory, kinetic molecular theory, is a human-made one. There are 5 main tenets or kind of assumptions regarding KMT. The first one is that gases are molecules that are continuous random motion. And along that, I'll also say they go in a straight line, right? Unless there is some kind of like magnetic field or some weird outside force, they're just going to keep bouncing along until they hit into something. The volume of each gas molecules is negligible, meaning basically not going to impact the total volume of the container. And this makes sense because these molecules here are so tiny compared to the size of the whole container that they're in. And so their volume is so small that it basically doesn't matter compared to how much space the total volume is in between them. So we can just assume that the volume that the gas molecules takes up is non-existent. That's our assumption. We also are going to assume that there are the attractive and repulsive forces between molecules is negligible. So again, that's basically saying that the gas molecules, they don't notice each other. If they were to run into each other, they just bounce right off. They're not going to get stuck together. They're not going to repel and have another outside force change their motion. The next one, which should actually be 4, is that energy can be transferred between the molecules during the collisions, but our average kinetic energy does not change. So basically, this is just like if I was playing pool or billiards, right? If I hit a ball that's stopped or is going slow, if I hit it with a fast ball, then some of the energy gets transferred. But the total energy is contained, or it does not change. And then the last thing, which is number 5, is that the average kinetic energy is proportional to the absolute temperature, or the temperature in Kelvin. So we know that though already. As the temperature increases, molecules are going to move faster, so their kinetic energy increases. So these are the 5 tenets that we're going to move forward with, assuming that this is how gases behave. And just FYI, by the end of the chapter, we're going to talk about when do these tenets break down and they cannot hold true.